So now another point, that if we have two plane mirrors, one here, and they are parallel, this is mirror M and this is N, and we have an object at this point. So if an object is placed in between two parallel plane mirrors, then the number of images is infinite. Let us see. Suppose this is object. The first image, suppose this is I1. Due to this plane mirror M, this image I1 is formed. Now this image serves as an object for this mirror, and its further image I2 is formed. Now this I2 serves as an object for this image, so here I3 is formed. So again I3, I4, again I5. So you see the images acts as object, and so the number of images becomes infinite. Now suppose this is one set. Suppose I say a ray, then it gets reflected here, and here you are an observer. Suppose this is the observer. So this observer sees image. Now this ray again gets reflected here and goes like this. So it gives an impression that this is the second image. Now in this way multiple images are formed. Now suppose this object serves as an reflects from this mirror, so its image here is J1, and this image further forms an image here J2 and so multiple images. So again, just like our previous example where we have two inclined mirrors, here we have two parallel mirrors, and two set of images I series and J series will be formed, and the number of images will be infinite. This we have seen in a sweet shop or in a barber shop where there are two plane mirrors opposite to each other, so the number of images is infinite. So now let us take up a question. Show that a ray after three consecutive reflections from three mutually orthogonal plane mirrors get anti-parallel to itself. So here we will use the vector expression of laws of reflection. So what the problem is, suppose this is a ray which after reflection from this surface gets here, and after reflection here gets anti-parallel. So this is one reflection, this is two reflection, this is three reflection. So here three plane mirrors are there. This is the plane mirror, this is the plane mirror, and this is the plane mirror. So this is XY plane, YZ plane, and this is ZX plane. So first reflection takes place here, then here, and then here. So this incoming ray and this outgoing ray is anti-parallel to itself, that we have to show. So here we will use the vector property, that is ER is equal to EI minus 2 n cap EI dot n. So this is the vector nature of law of reflection. We will use this property to derive this. Now let the ray be incident first here and it gets reflected. So the normal along this is along x axis, and this normal is called I. So let the incident ray direction be denoted by A1, A2, A3. This is the shorthand notation we will follow to describe the direction of incident ray. This direction means the incident ray is A1I. This incident ray is given as A1I plus A2J plus A3K. This is the direction of incident. What I mean by A1, A2, A3 is A1I plus A2J plus A3K. So this is how I represent in shorthand notation this direction, incident ray direction. Now here the normal is along this I direction. So what happens when the ray gets reflected, then only the direction normal to the plane mirror gets changed, inverted. So the direction of reflected ray after first reflection is, this is only I changing. So I A1 will become minus A1, A2, A3 will remain unchanged. So you see here, if we have a plane mirror here and some ray is going like this, which has in vector, it has this component and this component. So after reflection, this component is unchanged, only this component. So along the direction, normal to the direction component only changes. Here my normal is I, so only A1 becomes minus A1, A2, A3 are the unit vectors along this Y and Z direction. So now again the ray gets reflected here by this ZX plane, and here the normal is along J direction. So the direction of the reflected ray after second reflection is, now only J direction changes. So A1 is minus A1 minus A2 and A3 is. Now again the ray is reflected like this. This is the third reflection where the normal is along K direction. So the reflected ray, the direction of the reflected ray after third reflection is K direction only changes. So it becomes minus A1, minus A2 and minus A3. Thus you see our initial direction was A1, A2, A3. My incident ray was given as A1I plus A2J plus A3K. Now after reflection, reflected ray is given by A1I minus A2J minus A3K. So the direction is reversed. So the reflected ray is anti-parallel to the incident ray after three consecutive reflection from three mutually perpendicular plane mirrors. Now let us take another problem. Sun's rays are reflected from a horizontal mirror and fall on the vertical screen. An oblong object is on the mirror, and now we have to describe the shadow on the screen. So here this is a plane mirror and there is an object of height h. Light rays are coming from here at some angle, and because this is a reflected mirror, reflected rays are here, so this is an obstacle. So here there will be a shadow formed. So we have to calculate, if this height is h, what is the length of the shadow. So this is our problem. Now let us solve it. Now this is my object of height h, this is the plane mirror, and let us suppose the rays strike at some angle alpha. This angle is alpha. So the rays fall like this. Now what happens? You see this ray here just bounces and goes like this. So any ray here, any ray coming from here, and after reflection it will illuminate this region. So this region will be illuminated by this ray. What about this ray this ray gets reflected here, and so all the rays from this region will illuminate. So this shaded portion is the region illuminated by rays. Now here there is an obstacle, so all the rays from this region from here will be absent here, and so this becomes the shadow region. So this is the shadow region, and these will get illuminated by our light. So now we have to calculate this distance. We will assume that suppose this ray falls here, this angle is alpha. So this angle alpha, this angle is alpha, and here also this angle alpha. So we will write this A, B, this is C, this is D, E, F. So we have to calculate EF. So now you see, suppose this distance is assumed to be x and this is h. So we will get this distance as h. This distance will be h cot alpha, and if this is h cot alpha, this is x, so we will get this distance dE. Now dE by suppose AD, by AD we get as tan alpha. Tan alpha implies dE is equal to AD, that is x plus h cot alpha into tan alpha, that is equal to x tan alpha plus h. This is equation number 1, dE. So I got d, this is E, so this is F, sorry. So this is dE, write it as dF. Now let us calculate dE. This is x, this is h. So bx will be, sorry, this is dEF, let us write is G. So BG will be, BG will be equal to, you see this triangle, this is H, again BG. In order to calculate BG, we use this triangle BC by BG. BG is equal to again tan alpha. So we have BG is equal to BC cot alpha. Let us calculate GD. GD is equal to BD minus BG. So GD is equal to BD. BD is already we have assumed x, minus BG, also we got BC is H cot alpha. So this is our GD. Now again in this triangle ED by GD is tan alpha, implies ED is equal to, ED will be equal to GD tan alpha. So ED is equal to GD. What is GD? We got x minus h cot alpha into tan alpha, that is x tan alpha minus h. So this is ED. Now the shadow region is equal to EF, that is equal to DF minus DE, that is equal to DF is x tan alpha plus h minus again x tan alpha plus h. These two cancel, so becomes 2h. So thus we see that we got this height as 2h. So the region where the shadow region will be has a width 2h if this object is of height h. Now let us take another problem in which we had a plane mirror, 4 plane mirrors forming a rectangle. Suppose this is a room, we have a room in which all the 4 walls are made up of plane mirror, and we have a point light source at S. Now we have to determine geometrically that how should I select my ray diagram, ray incident on this plane mirror, so that after reflection it passes through B. This is A, B, C, D. So I have to determine geometrically that what is this ray direction, so that when the ray goes like this, reflects, then it passes through this corner. So this is my problem. So how to do this problem? So what we will take up, we will draw another similar rectangle here. So now what we will do, we will join this point S with this point. So if I join these 2 points, now when I join these 2 points, then this direction is the direction in which after reflection the ray will go like this. So the step what we have to do, this is B and this is B dash. So join S and B dash. So this point, so when I join this, that means this is the direction in which the ray should be incident. So after reflection, because you see the reflection of B in this AD is B dash. So the ray must go like this. Now let us another take up a problem. What should be the direction of S, so that the point, so that the ray after reflection from here it goes like this. So now in this problem we have to select a direction in which the ray should be incident on the mirror AD, so that after reflection it passes through this corner, incident and C. This is my problem. How should I select the direction, so that after 2 consecutive reflections from these mirrors it passes through C. So this is our problem. So now what we do, this mirror is going to reflect, so we will construct a similar rectangle here. This is on this side. Next, so this is the first reflection. So it is now again after first reflection it should reflect from here. So again a similar rectangle we will construct this way. Now the image of B is going to be at B dash and the image of C is going to be at here C dash. So what we will do, we will join these 2 points. Now we will join these 2 points. So when I join these 2 points, that means I get this direction. That means if the ray is incident like this, then it will get reflected like this, and so it will pass through this. So in this way, by constructing its mirror images and joining S and C dash, we get the direction in which the light should be reflected, the light should be incident. So after consecutive 2 reflection, it passes through C. This is the ray diagram to do that. Now in this problem again we have 4 plane mirrors making a rectangle, and this is point A and this is point B. I have to find out a direction in which I should start my ray, so that after reflection here, from here, again here, again here, again here, it should pass through B. So I have to select a direction such that after consecutive reflections from the walls, it should pass through B. This is our problem. So what we have to do here now is, first we will start with B. We will drop a perpendicular on this plane mirror. Now we will drop a perpendicular here. So the image of B on this mirror will be B dash. Now next, again we draw a perpendicular on this line and extend it. Suppose this is equal to this should be equal to this, that, so that the image of B is B double dash formed in this mirror. Now again we drop a perpendicular from B dash on this wall this plane mirror so that it extends equally. So this side should be equal to this side. So B triple dash forms the image of B double dash, B double dash forms the image of B dash, and B dash is the image of B. Now again, on this plane mirror, this B triple dash is there. We again draw perpendicular here and extend it equally to B4. So now what we do, we join these 2 points. These 2 points. So you see, now when I join these 2 points, we got this ray. So this is the direction in which, so you see, when this wave gets reflected, this is the image of this. So this wave after reflection form my image here. So now next, if I join this here, so the ray goes like this. So when we produce further, it will go like this. Now when I join these two, you see the ray goes like this, and then the ray gets reflected. So in this way, if I join these 2 points, then the ray in this direction after consecutive reflections will pass through B. This is how to draw the ray diagram for multiple reflections like this. So now let us take a question here. This is a room which has a square floor. We have 4 walls as acting as a plane mirrors, and we have a ray which is horizontal and incident at an angle theta with any of the wall. So this ray has to come out from any number of reflections. Suppose here 1, 2, 3 reflection. If it is 45 degree, it will come out here. If it is something, it will come out like this. So it has to come out from any of the small openings. These are the rectangular openings at the corner. So the angle, you have to find what angle theta will be for which the rays will come out after any number of reflections. So here I have given some options. Number A, tan theta equal to 1, tan theta is equal to root 2, tan theta equal to 3, and tan theta is equal to 99 by 100. So this is my problem. We have 4 mirrors and we have to find the angle theta at which the ray will come out from any of the slits here after any number of reflection. It may come out from here, 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 even from here also. So the correct option here is actually this is correct, this is wrong, this is correct, and this is the correct option. So let us see how only this B is wrong and why A, C and D is correct. So now look at this. Here is our room with all the 4 walls as the plane mirror, and here is the ray incident at some angle. This angle is theta. In order to determine what should be this theta, what we will do, you see, first ray is reflected here. So we will draw another square this side. So the ray, you see, the ray gets reflected like this. That means we can extend my rays to like this. So this point as a mirror image here. Now the ray is reflected again like this. What we do is again draw a square this way, so that when we extend it, you see this ray is represented like this. So this is one reflection here, this is another reflection here, there is one more reflection here. So I just draw this by this triangle. Then again the ray goes like this. You see the ray, if the ray passes here, that means the ray will actually come out like this. So this is the opening and the ray just comes out. So if the ray has to come out after one, you see reflection, second reflection here, third reflection here, and fourth finally comes out, that means the ray will pass at the lattice point of this. So what we have to do, we will draw a grid of squares like this, and so when this ray passes through any of the grid, suppose this ray has passed through this grid, that means the ray comes out. If it passes through this grid, that means after reflection from here it would have passed like this. So suppose this side is A, then if it has to come out from any of the grid points, any of the slit, that means it must pass through any of the grid points. So this will be m times A. This side will be m times A and this side will be n times A, where m and n are positive integers. So the angle theta is given by tan theta is equal to NA by MA. That is, theta is tan inverse N by M, where N and M are integers. So whenever this tan theta is some integer by integer or a rational number, then whenever tan theta is a rational number, then the ray will come out from the slit. So tan theta is equal to root 2 does not allow the ray to come out from the any of the slit. So my options were, multiple options were there. Tan inverse 99 by 100, that means 99 times here and 100 times here. So in this way, by constructing this grid, we can calculate, we can find out for what angles the ray will come out.